Good evening to everyone. Today we are going to discuss about the topic two-way classification. As we have discussed about the one-way classification in the previous video, now I am going to explain you about two-way classification. In the name itself, it is two-way classification. That means we are going to have two factors. For example, we are going to take the treatments and varieties. Okay, that means we are going to take for example schools and particular ages of the students. Like that we are going to compare these two. Okay, where we are having in two ways, that means between the treatments and between the varieties, we are going to discuss in your two-way classification. Okay, as here we are going to discuss about the procedure for problem based on two-way classification. Here, set the null hypothesis. See, as we are having two ways and as we are having the treatments and varieties, we will be having two null hypotheses. One is of H01 and one is of H02. Now, and the second step will be calculating the grand total G. And the third step is correction factor, that is G square by capital N, where N is here. We are going to multiply the number of treatments with number of varieties. Okay, K is nothing but we are going to have number of treatments or number of varieties, that is your wish. And H is your number of treatments or number of varieties. Okay, here calculate the raw sum of squares. Not its rho, it is raw sum of squares. As you already know that raw sum of squares is nothing but squaring each value and adding. Okay, that means x square plus y square plus z square, like that. Similarly, whatever you will be having, still there you are going to find out. Now, calculating the total sum of squares. Total sum of squares is equals to formula RSS minus correction factor. Calculate the treatment sum of squares. Here, in your treatment sum of squares, you will be having sum of squares due to treatments. It is denoted by SST, which is equals to summation I T I dot square by H. H is nothing but here number of varieties. Okay, so minus correction factor. Now calculate the variety sum of squares, that is SSV. SSV is equals to summation J T dot J square by K minus correction factor. You may take the rows or as varieties and columns as treatments, or rows as treatments and columns as varieties. That is your wish. Particularly based on the question, you have to see that. Okay. Now, calculate the error sum of squares. That is sum of squares due to error, which is denoted by SSE, is equals to total sum of squares minus sum of squares due to treatments minus sum of squares due to varieties. Now we are going to compute the ANOVA table, and the last step is nothing but we are going to draw the conclusions. Okay. Now we will be going to discuss about the problem based on that. See, 4 varieties of potatoes are planted, each on 5 plots of ground of the same size and types. Each variety is treated with 5 different fertilizers, and the yield in turns are as follows. They have given that yield in turns as follows for particularly plots and varieties of 5 different fertilizers. Okay, so 1, 2, 3, 4, 5, and the varieties are 4. That means they have been given the varieties as 4, and the treatments you can consider this side, that is of 5. Okay, this is nothing but your number of varieties, and this is nothing but your number of treatments. Okay, perform ANOVA and show whether there is any significant difference between the yields of different varieties due to different fertilizers. This is the question. See, whereas in your one-way classification, we are going to check only in a one way, either treatments only. But here we are going to check that both the treatments and varieties. That is the difference between the one-way classification and two-way classification. Here K is equals to 4, that is H is equals to 5. K is equals to number of varieties. We are going to have 4, that is 4 varieties. 4 varieties are there. And H is equals to number of plots which we are considering it as treatments. That means this columns, 5 columns are there, that will be you are considering as treatments. Okay, I already told you that N is equals to KH. KH is nothing but the number of treatments into number of varieties. That is 4 into 5. You get the value of N is 20. Okay, now we are going to calculate the totals for this one. See, whereas in your one-way classification, either we are going to do only the row-wise totals, but in your 2 by 2, that means two-way analysis, we are going to find out the K by H analysis. Okay, K by H table, where already they have given plots, 5 plots and varieties as 4. We are going to find out the totals for each. That is Ti dot, where Ti dot means we are going to represent that the values of your varieties are changing. Okay, the totals you are going to write. By adding all these things, we are going to get this. Here, this. By adding 1.7, 1.9, 2.2, 2.1, you are going to get 9.9. Similarly, you are going to add the totals for the plots also. These are the totals for varieties and these are the totals for plots. Now, where we are going to get the totals both will be here the grand total G. This will be same. If not, your answer is wrong. Okay. Now, this you are going to find out the Ti dot square. That means 10.6 square, which is 112.36. Now, 11.5 square, that is 132.25. 9.9 like this and like this. And this will be T dot J square, that is 8.2 whole square here. Here it is 7.8 whole square and here it is 9.6 whole square and here it is 8.7 whole square and 8.8 whole square. Okay. By adding all these things, you are going to get 373.37. Here also, we are going to get 465.83. Now, you already know that grand total G is nothing but 43.1. From here, you are going to get, and correction factor CF is equals to G square by capital N, where G square is nothing but 43.1 whole square by 20. Now, correction factor, you got this as 92.8805. As you already know that the raw sum of squares formula is summation I summation j xij square, where each and every term of your given question, that is 1.9, 2.2, these will be squared and added. Okay. So, here we are going to write that 1.9 whole square plus 2.2 square plus 2.6 square plus 1.8 square plus 2.1 square still up to so on. All these lines will be squared and added still up to 2.4. You are going to get the raw sum of squares as 94.31. Okay. Now we have to find out the value of total sum of squares. What is the formula for total sum of squares, ma? TSS is equals to RSS minus correction factor, where RSS is nothing but 94.31 minus correction factor, that is 92.8805. You are going to get the total sum of squares as 1.4295. Now, sum of squares due to varieties, where SSV is equals to, I already told you, the sum of squares due to varieties is going to be in the denominator the number of treatments. I already told you that the number of treatments here are 5. Okay, minus correction factor. Now, sum of squares due to varieties, you got this, and sum of squares due to plots, that is treatments, you are going to take that summation T dot J whole square by K. How much it is of, ma? It is 373.37 by K. K means the number of varieties you are going to write, that is 4, minus correction factor. So, sum of squares due to treatments you got as 0.462. Now, sum of squares due to error. I already told you the sum of squares due to error is equals to SSE, which is equals to total sum of squares minus sum of squares due to treatments minus sum of squares due to varieties. After subtracting these two from the total sum of squares, you will get SSE. Okay. Now, we are going to form the ANOVA table, the next step in your processor. That is, as you already know that these are the columns which you will be having in your ANOVA table. Sources of variation, degrees of freedom, sum of squares, mean sum of squares, and F ratio. Here, see, in your one-way classification, you will be having only the treatments, error, and total. But here, we are going to find out the variation between the treatments and between the varieties. So, here between varieties and between treatments. You already know that how many varieties you are having? K minus 1. And how many treatments you will be having? H minus 1. So, K is nothing but your varieties, that is 4. 4 minus 1 is 3. And here it is H minus 1. Number of treatments you are going to treat it as 5 minus 1, that is of 4. The error formula is K minus 1 into H minus 1. That is 3 into 4, 12. The total sum of squares, the total degrees of freedom is equals to n minus 1, that is equals to 19. 20 minus 1, you will be getting 19 here. And the sum of squares due to varieties here you are writing, sum of squares due to treatments you are writing here, and sum of squares due to error you are writing here. And this will be the mean sum of squares due to varieties, and the mean sum of squares due to treatments, and the mean sum of squares due to error. How you are going to get this here? Sum of squares due to varieties by K minus 1. Sum of squares due to treatments by H minus 1. Sum of squares due to error divided by K minus 1 into H minus 1. You are going to get the mean sum of squares. I already told you that the F ratio will be having two values of F1 and F2. Why? Because here we are having two ways, that is between the treatments and between the varieties you are going to find out. That's why you will be getting two conclusions. Okay. One is of F1. F1 is the formula. The mean sum of squares due to varieties by mean sum of squares due to error. Always the value of error will be coming in the denominator only. Okay. So F1 is equals to 0.0952 by 0.0568. You will be getting 1.68. Now F2 is equals to 0.01155 by 0.0568, which is nothing but 2.03, which you are going to compare at F table value for the degrees of freedom 3, 12 and 6, 12 for the second one. 4, 12. Okay. Now, here you may get the conclusions, two conclusions. No, the conclusion for the first one, that is F1 calculated value is less than F table value. The F table value you have to check from the tables. Okay. So F 1.68 is less than 3.49. That means you are going to get the less than value. What you are going to take now? We accept the null hypothesis H01. Where H01 is, that means there is no difference between the varieties. And here the second one is F2 calculated value is less than F2 table value. That is 2.03 is less than 3.26. Therefore, we accept H02. There is the significant difference between the fertilizers, that means plots, is not significant. Understood, ma? Thank you.